Hi students, so in this video we'll be starting our next topic, which is your EMF of the cell. Now what is actually EMF of the cell? You studied about electrode potential in the last videos, right? So EMF of the cell is nothing but the difference between the electrode potential in both oxidation and reduction side. That is your EMF of the cell. It can be basically defined by a formula as well. EMF of the cell, which is represented by E of cell, will be equal to your E of cathode minus E of anode. E of cathode minus your E of anode. That's how your EMF of the cell is. Like just remember this trick, ECA. E cathode minus E anode. CA. Okay. Now, how do you get this formula? You must be knowing this electrolytic cell, right? On the left hand side, there was an oxidation reaction happening. On the right hand side, there was this reduction reaction happening, and these both were connected by an ammeter. So on the left hand side, your oxidation was happening, right? So suppose M was giving you Mn plus plus N electrons. So what kind of, like here you are getting Mn plus, and electrons will be traveling here from your this part, that is your anode, to cathode. So here what kind of electrode potential you will be getting? Oxidation potential, right? M is getting converted to Mn plus, and supposingly they have given us a value of minus 0.2 volt. This is your oxidation potential, right? Because here you can see there is oxidation happening. Here what is happening? Your reduction will happen, right? So electrons from this electrolyte will get sticked here. So Xn plus will accept electrons from here so that you get a metal. So here what you'll be getting? E of your Xn plus, and X is your plus 1.8 volt. Like this is a value I have given you, 1.8 volt. This is actually a reduction potential. How do you define, how do you guess what is an oxidation potential and reduction potential? For oxidation potential, your metal will be written here, and metal is getting oxidized. So Mn plus. Reduction just the opposite. Xn plus is accepting electrons to give you X. And what is EMF? Difference between electrodes of the cell, right? So EMF of the cell, that is your E of cell, here will be 1.8 minus, like E cathode, this is your cathode, right? So E cathode minus of E of anode. So minus 0.2 volt. So you'll be getting equal to 2 volt. Right? Now how does this formula came? Just check here, how did this formula came? We know EMF of the cell will be equal to your E of oxidation potential plus E of reduction potential, right? This was for anode and this was for cathode. Now if I want to, like if I want everything in my reduction potential, what will I do? Minus of E of reduction potential of anode plus E of reduction potential of cathode. So I'm just writing it in the opposite way. You'll get E of cathode minus of E of anode. That's our formula, right? So this is how you find the EMF of the cell. What is EMF of the cell? Nothing but the difference between the electrode potential of both the cells, right? So I'll be giving you questions for finding the EMF of the cells. But before that, a quick revision. We studied about E of cell, right? Now there are two kinds of E. One is your E of cell and the other one is your E naught of cell. E naught means under standard conditions, standard EMF of the cell. Now this E of cell is not standard, and it can happen at any concentration and temperature. This one can happen at any concentration and temperature, and this we find it out by Nernst equation. And this E naught cell, simply it means that it is standardized in standard conditions at 25 degrees Celsius, 1 molar, 1 atm, 1 bar. Here you can find the standard electrode potential is E naught of cell will be equal to E naught of cathode minus E naught of anode. That's how you find your E naught of cell, like how we did previously. So now I'll be giving you some questions related to this. So like first question, do it with me. Next questions, just pause the video and try it on yourself. So the question is, find standard, just be careful of each and every word in chemistry. Find standard cell potential. You have to find the standard cell potential. That is, what is standard cell potential? E naught of cell. You have to find the E naught of cell for this particular reaction. Ni is giving you Ni2 plus. What is this? Oxidation or reduction? Ni, first what is coming? Ni is coming. So Ni is losing electrons to give you an ion, Ni2 plus. So it means oxidation. Oxidation is loss of electrons, right? So Ni is giving you Ni2 plus. And whenever there are ions, they'll always write molarity, maximum cases. Here is your Sol bridge. This is how you represent a cell, right? And then it is giving you Ag plus. Now since this is ion, I am writing my concentration also is giving me Ag. Here my reduction is happening, right? First, like start reading from your left hand side. What is happening? Here my oxidation is happening and then the Ag plus reduction is happening. And what they have given, whatever I am writing in black, these are all given values, okay? So E naught of Ni2 plus and Ni is equal to minus of 0.25 volt. And the second one, E naught of Ag plus and Ag is your 0.80 volt. So this is your question. What we need to find? We need to find the standard cell potential. Now standard cell potential, we know the formula. We know the formula of standard, how to find the standard cell potential, right? E naught is equals to E of cathode minus E naught of anode, right? So whenever such kind of question comes, your step 1 should be check the notation, which is anode, which is cathode. First step, whenever these kind of questions come, check which is anode and which is cathode. Now how do you check which is anode and which is cathode? Like the same trick I told you, right? Here whenever the oxidation is happening, left side, you remember lone, left side oxidation is happening, that's your anode, right? So this thing will be your anode and this thing will be your cathode, correct? This is the first thing which you need to notice, which is anode, which is cathode. So whenever the oxidation is happening, that side is your anode and the rest of the side is your cathode. So once you have checked, then you check whether, second thing which you need to check is, check the E naught value. Check the E naught value. Check the E naught value is given in terms of oxidation potential or your reduction potential. So E naught value, here are their E naught value given, right? So we need to check whether it is given in terms of oxidation potential or reduction potential. Now see, check here. What is happening here? Accepting electrons, right? So it's a reduction potential. Reduction potential value is given because accepting electrons. Ion is written first, so that means reduction is happening. Similarly here, you can see here also reduction is happening. So everything is correct. But if in case, if they would have given in terms of oxidation potential, like suppose if they would have been giving you in this term, Ag plus is minus 0.80 volt. Here your reduction, oxidation potential value is given, right? Because your oxidation is happening. What you need to do is, you need to reverse the sign. You need to reverse the sign. So here when you reverse the sign, you will get 0.80, that will be your reduction potential. Correct the third thing, simply apply the formula. E cathode minus E anode, right? So here you don't have to do much hard work. E naught of cell will be equal to E naught of cathode minus E naught of anode. So what is the E naught of cathode given to you? Which one was your cathode? Cathode was Ag plus. So this will be 0.80 minus E naught of anode. What is your anode? Ni, right? So minus of minus 0.25. Minus and minus will become plus. 0.80 plus 0.25. This one will be 5011.05 volt. Don't forget the units. So E naught of cell, the standard cell potential of the cell is 1.05 volt. So again I am telling you what you need to do. You need to first check which is anode and cathode. Next, we need to check whether the E naught value is given in terms of reduction potential. If it is not given in the terms of reduction potential, just reverse the sign. Same value, just reverse the sign. Then apply the formula, you will get the standard cell potential. More questions will do it. Just try it on your own. After I write the question, just pause the video and try it on your own. So the question is, you have to again find E naught. Find E naught for this cell. So your cell is Zn, Zn2 plus, here you have Cu2 plus 1m and Cu. Here your E naught values are given as Zn2 plus zinc is your minus 0.76 volt and your E naught of Cu2 plus and Cu is given as plus 0.34 volt. You need to find the E naught. How will we start? We'll first check which one is anode, which one is cathode. So can you see here oxidation is happening. Wherever your oxidation is happening, that thing is your anode. Wherever your reduction is happening, that thing is your cathode. So we have identified which one is your anode, which one is your cathode. Next thing which we need to be sure of is whether both the E naught values are in the reduction potential. Now you can see here and here, both sides the reductions are happening, right? Cu2 plus is converting into Cu, like iron is converting into Cu, and Zn2 plus is also converting into Zn. So both side your reduction potential value is given, right? So this is also done. Next, third thing, very easy. You need to just apply it into the formula. What was the formula? E naught of cell is equals to E naught of cathode minus E naught of anode. Which one was your cathode? Cathode was your copper. So first apply this value, 0.34 minus of minus 0.76. 9, 10, 0, 1, 10, 0. So this thing will be your E naught of cell. Okay. Next question. Last question we'll do from this topic. Next question is telling you, you have to find the E naught for this reaction. For this cell representation, find the E naught. Zn, Zn2 plus 1m. And your E naught values are given as okay, just pause this video and try it on your own. What will be the E naught? First, what we need to check? We need to check which is cathode, which is anode. Obviously, anode. You remember the term? Lone. Left side oxidation happens. Wherever the oxidation is happening, that is your anode. So here your oxidation is happening. So this is your anode and this thing is your cathode because reduction is happening. Then what we need to do? We need to check whether the E naught value given is in the terms of reduction potential. But can you see some differences here? Here reduction is not happening. This is actually your oxidation which is happening, right? It's losing some electrons to give you iron. So what we need to do in order to convert it into reduction potential, just change the sign. Minus of 0.76 volt and minus of 0.13 volt. Then what we need to do, just apply the formula. E naught of cell is equals to your E naught of cathode minus E naught of anode. What is E naught of cathode? Which one was your cathode? PB. So minus of 0.13 minus of minus 0.76. So this will approximately come out to be, so this will become minus of 0.13 plus of 0.76. So it's actually a 0.76 minus of 0.13, 0.63. So this will be 0.63 volt. Okay, just remember EMF of the cell can come negative also. The final EMF can come negative also. But that will ultimately mean that the spontaneity is not that much. The cells are not that much spontaneous. Okay, so this is how you calculate the EMF of the cell. What is EMF? The difference between the electrode potential of both the half cells. Right? Next topic which comes is a very important topic to check the feasibility of the cell reaction and Gibbs free energy. See, if we are having any kind of cell, what is the point of having that cell if that cell is not working, if that cell is not feasible? Like, what if the cell is, not transferring electrons, not giving me the electricity? What is the point of having that cell? No point, right? No point in having a very slow cell also. So, in order to check which kind of cell we can make, there is a formula to check the feasibility. So, next topic is, put the heading as feasibility or spontaneity of cell reaction. Feasibility or your spontaneity of cell reaction and your Gibbs free energy. Gibbs free energy, don't bother that much for now because we are going to convert Gibbs free energy in detail in our thermodynamics chapter. So for now, just remember what is delta G. Delta G is change. Wherever delta comes, delta means change. So delta G, that is your change in Gibbs free energy. Change in Gibbs free energy is your minus of useful work done. See, whenever your Gibbs free energy is negative, it means you have spontaneity. That reaction will be feasible. Whenever your delta G is negative, just remember this thing for now because rest everything will come in thermodynamics. So delta G is minus of useful work done. Minus of useful work done by the system. So I can write it as like minus W also, right? So delta G equals to minus W. I am just naming it as 1. This is actually your electrical work, right? The work is electrical. Now also I know electrical work, like, if I take another formula like potential difference formula, this all you will study in your physics. Potential difference formula is your work done by charge. Potential difference formula is work done by charge. Now what will be the work done here? Like just cross multiply potential difference into work, right? So potential difference is usually represented by U and charge is represented by Q. W is your work done. So here if I take this formula, I'll be getting W is equals to delta U into Q. Q delta U. So let's name this as second. This is just a derivation. How does this feasibility final formula will come? So this is my second thing. The third thing which you need to calculate, like supposingly you have an electrochemical cell, N electrons are getting transferred from anode to cathode. N moles are getting transferred. Suppose N moles are getting transferred. So then what will be your q? Q will be charge that is present on your one electron multiplied by total number of electrons. Charge on one electron multiplied by total number of electron. Now this is just a theoretical topic, that charge on one electron is 1.67 into 10 raised to the power minus 19 coulomb multiplied by number of electron, that is your n, and number of electrons we don't know, right? And number of electrons can be 6.02 into 10 to the power 23. When you just calculate this thing roughly, it will come out to be n into 96485 coulomb. And this thing is called as Faraday. This is like charge on 1 mole of electron. Faraday, charge on, this is your charge on 1 mole of electron. So we can just write it as N and F. This is your third equation. And your potential difference, like for potential difference of the cell, you can also see potential difference will be equal to, potential difference will be equal to your E of cell, electromotive force of the cell. Now what are we going to do? We will just substitute the value of 3, 4. This is my third, this is my fourth thing, right? Third and fourth in second and first. First what I'll do is I'll just substitute 3 and 4 in 2. So W, we don't have anything for W. Q, we have NF, and delta U is E of cell, right? E of cell. Now if we substitute this one, substituting fifth and first, what are we getting? Delta G equals to, minus sign will come, NFE cell. This is your major formula. Delta G. To check the spontaneity of the reaction, what is your major formula? Delta G is equals to minus NFE of cell. Again, I'll tell you guys how did this happen, how did we arrive at the final formula. Like, this is not that important. You can skip this point of derivation if that's not there in your course, because some schools do ask them. So how do we calculate if the reaction is spontaneous or not? We'll find through delta G. Delta G is always equal to minus of work done by the system. So delta G is equals to minus of W. Second thing which you need to calculate, what is this work done? This work done is actually the electrical work done. So electrical work done, we just, like took another formula, potential difference is equals to work done by charge. We just cross multiplied it, we got work done equals to Q into delta U. Then third, what we need to calculate, this Q and U. Q we are calculating as charge on one electron, number of electron, we got N into F. F is your charge on 1 mole of electron. And then delta U will be equal to E of cell. Substitute everything, you'll be getting delta G is equals to minus NFE. So whenever your delta G is negative, when the cell is spontaneous, the first condition, like the important condition, is your delta G should be negative. Delta G, what is the main formula? Delta G is equals to minus of NFE naught of cell. E naught, just remember, NFE naught of cell. So whenever your delta G is negative, then the cell is feasible or the cell is spontaneous. Or you can also tell it like this also, right? When E naught of the cell is positive, E naught is positive, then your cell is spontaneous. Because if you do E naught of cell as negative, then negative will become positive and delta G will also become positive. So either your delta G should be negative, and not either, and E naught of cell should be positive, then only your cell will be spontaneous. Alright, we'll do some questions based on this, just 3-4 questions, and then we'll start with the next video for Nernst equation. Okay, the question is, find find E naught of the cell and predict the feasibility. Predict whether this reaction is actually possible or not. Predict the feasibility of the reaction. And what is the cell? Zn, giving you Zn2 plus 1m salt bridge, Cu2 plus 1m and Cu. You have to predict the feasibility. What values are given to you? E naught of Zn2 plus. So there are some concepts which were there in the previous topics also. And always your 1 Faraday value is also fixed, which is your 96,500. 96500. Okay, so this is your question. All these values are given to you. The first part is very easy, that you need to find the E naught of the cell. So you remember, first we need to check what is cathode, what is anode. How do we find the E naught of the cell? Just remember this formula. E naught of the cell is equals to your E cathode minus E naught of cathode minus E naught of anode. First check which is cathode, which is anode. Here your oxidation is happening, right? So wherever your oxidation happens, that's your anode. Wherever your reduction happens, that's your cathode. So we now know what is anode, what is cathode. Then we need to check whether your E naught value is your is given in terms of reduction potential. Now can you see both are reduction only, because Zn2 plus is accepting electron to give you Zn here, Cu2 plus is accepting electron, so both are right. Then just substitute in the values. Which one was your cathode? Cathode was this, anode was this. So 0.34 minus of minus 0.76. This will become positive. 7, 8, 9, 10, 11, 1.1 volt. This one will be your value for E naught cell. Now we need to predict the feasibility. What was the formula we were applying in feasibility? Delta G is equals to minus of N Fe naught. If it is coming negative, that it means it is correct. How do we find N? N means the number of electrons. So just write the cell reactions here. What will be the cell reaction? Zn giving you Zn2 plus 2 electrons. Cu2 plus is accepting 2 electrons to give you Cu. So can you see the total number of electrons is 2? So here your N will be equal to 2. So this will be minus 2, 96500 multiplied by 1.10. So when you solve this thing, the final answer will be negative. So that means the cell is feasible. Yes, the cell is feasible. Okay, next question. Next question is also the same. You have to find the feasibility of the reaction. To find the feasibility of the reaction. Now, what reaction I am giving you is Ni plus 2H plus is giving you Ni2 plus H2. And what are the values given? Values are E naught of Ni2 plus and Ni is your minus 0.25 volt. So there are two things which you can from which you can find it out. You can either find it out by whether your E value is positive or whether your G value is negative. To check the feasibility, you need to check either of the two things is fine. So you can see finding the E naught value will be quite easy, right? Because E naught of cell equals to E naught of cathode minus E naught of anode. Now, how do you check which is cathode, which is anode? Can you see nickel is giving oxidation? Whatever is giving oxidation, that's your anode. So, this is your anode and hydrogen will be your cathode. The other one accepting electrons. So, reduction happening. So, this one will be your cathode. So, 0 minus of minus 0.25, which is equal to 0.25. So this is plus 0.25. E value is becoming positive. That means the reaction is feasible. Okay. The last question from this topic. It's a little bit logical question. Can we stir zinc rod in your CuSO4 solution? You need to check whether we can stir this thing under standard condition. Like, what is our fear? What is our major fear? You have a CuSO4 solution and zinc rod. They are asking, can we stir this thing? Because what fear we have? We have this fear, what if the zinc dissolves in the CuSO4? What if the reaction becomes feasible and the zinc rod suddenly disappears all of a sudden? That's a main fear, right? So CuSO4 solution has Cu2 plus and SO4 2 minus ions, correct? So what are we going to do? We are taking zinc. This will be a reaction. Cu2 plus and zinc rod will undergo oxidation, obviously, right? Because zinc will undergo oxidation and here you have Cu2 plus ion. So Cu2 plus will accept electron. This is just a half cell, not a half cell, like this is just a container. It's giving you Cu. So zinc is undergoing oxidation and your copper is undergoing reduction, right? So just calculate E of cell. Okay, two things I forgot to give you, the E naught values. The E naught values for Zn2 plus and zinc is your minus 0.76 volt and E naught value of your Cu2 plus and Cu will be your 0.34 volt. So E of cell, just apply the formula, E of cathode minus E naught of anode. Which one was your cathode? Cathode is this one because it's undergoing reduction. Whatever is undergoing reduction, that's your cathode. So 0.34 minus of minus 0.76. So E naught is coming positive, obviously, right? 1.10 volt. So because it is becoming positive, you get E of cell as positive. So E cell positive, whenever it comes, it means the reaction is feasible. So reaction will happen. Zinc will dissolve in copper. So it is not advisable to stir zinc rod in CuSO4 solution. Okay. So with this, we complete the feasibility of the reaction topic. And now you know how to find the E naught of the cell. You know how to check the feasibility of the reaction. Everything we know. So next video we'll be checking the Nernst equation and a quick revision of all the topics which we have studied till now. So I hope everything is fine, and whatever doubts you guys have, you can mention it in the comment section. Okay then, thank you so much.